All right, welcome everyone. I'm going to try to start on time just to make sure to be respectful to the next speaker. Hi, I'm Marshall. I'm here to talk to you about open source GenAI on OpenStack. This is a collaboration between Indiana University and Infotran. And basically what we are doing is that Indiana University was kind enough to grant me a very powerful OpenStack instance with an NVIDIA H100, which we're going to be using as long as the Wi-Fi is with us to do live demos of image generation. Some of them are going to be fairly fast. The last one might take a minute to generate, which, given that I have an H100, would be 5 to 7 minutes on other hardware. So with that, let me just talk to you slightly about the people that were supposed to be here today. Julian and Mike unfortunately cannot join us, but Julian is the founder and maintainer of the Exosphere project. Exosphere is a really wonderful front end for OpenStack that make it possible for you to get your VM and have access to a Guacamole front end, meaning that you have a GUI on top of your VM and you can do a ton of things on top. Julian is part of the Jetstream project, and Mike is the project lead for the Jetstream project. And Jetstream is basically a way for you to get access to really powerful hardware provided by American universities to do research. Hi, I'm Marshall. I am the Chief Technologies VP of AI and Data Science for Infotran. I do AI, right? I do a lot of stuff that are related to DevSecOps, to standards, and obviously GenAI. What am I? Really, I'm a builder. I'm a guy that's basically going to be designing technology, and usually the conversation is not about building. It's about what's possible versus what we can actually give to people. And those are not always the same conversation. I've been doing that for quite a while. I have a PhD in distributed computing. I did distributed computing when it was hard. Nowadays, a lot of the thing is either massive parallelism or trying to schedule the job as best as you can. I am co-author and co-chair of multiple standards and or SP 500 on Cloud Federation. So I've been doing cloud for quite a while. And I am the co-chair for the OpenStack Scientific SIG. So all of that to tell you, I've been around, I'm doing a couple of things. Hopefully you guys will enjoy what this demo is about. Everything has been designed so that it should run on 24 gig of VRAM for people who want to play at home, because the code or the workflows that we're going to be used are going to be released right after that presentation. So just in case you meet one of us live, here is what we look like. That would be Julian, Mike, and myself. Obviously, maybe slightly altered, but that's actually one of the examples we're going to be talking about today. So Jetstream 2 is what I said earlier. Gives you OpenStack on-demand access to really powerful HPC hardware. And we're talking really powerful. So for people who are curious, it's distributed across 5 sites. I highly recommend you look up the Jetstream website or the Jetstream 2 video from Scale. Julian and I were at Scale this year, and we basically had a chance to demonstrate. Julian had a chance to show up all the wonderful resources that you can get access with Jetstream and how it helped democratize some type of research. If you are curious, this is the instance that we're going to be running on. This is a 240 gig of RAM, which is not super important for that one, but if some of you were there yesterday when I was talking about large language model, this is part 2, by the way, of the talk. Yesterday I did a presentation on large language model utilization using a tool called Core AI, which I maintain. And the idea was that we did a search agent, we did a retrieval augmented generation, we did VLM, vision language model, and we did image generation using code. All of that is also going to be available as Jupyter notebooks for you to play with if you're curious as part of the GitHub. What I said earlier, H100, 80 gig VRAM, super powerful GPU. You're going to see we're going to be able to generate videos in 1 minute. So this is a nice box. How are we going to do it? Well, you heard me say I'm a builder. So Comfy UI is a great front end with a lot of spaghetti node. And by that, and yeah, I'll show you an example in a minute, is you're going to have ways to interconnect nodes. A node is basically a piece of Python code that basically has input and output. And each one of those input and output are what's going to be supporting the image generation. So you have multiple type of nodes. You can build a ton of workflows. It's not limited to image generation. You can actually build nodes to do audio and video, or actually text processing. I've seen people do and or on text. So you can also integrate LLMs into those type of workflows. It is extremely customizable. There is a ton of custom nodes out there. The trick is you have to basically follow AI news. Every week there is a new model, right? Every week there is something new fancy that you want to try. And I try to do that. It takes a lot of time. The way you work with a workflow is that you're going to pipeline your process. So you have a prompt, right? You say, I want a giraffe. Then what happens is that it encodes it so that the large language model is able to transform the information into data that is usable by the model that you're using. So basically, if you say a giraffe is a specific class inside the model, that's how it gets translated. Then what you have is that you have noise. You have what is called latent noise, and the sampler is what is going to be refining the noise in order to decode and generate the output. Now, before I go too deep, because I can go really deep in that conversation, it's a massive parallelism problem. What that means is that if you have a system with a ton of cores, it's going to work way faster than if you have a system with less nodes. So the more cores you have, the faster it is. So for LLM, I would say you can run on ARM, you can run on whatever you want. It's always going to be great. For stable diffusion, if you have an NVIDIA GPU or a ROCm, something where an AMD, as long as the number of cores matters more than the methods that you're using to build. So I talk about Comfy UI and the fact that I'm a builder, right? You might notice that GitHub is mine. I've been supporting a Docker image for Comfy UI for a year and a half. Maybe a year and a half nearly. And I built it out of curiosity, right? I was like, well, I need something to run Comfy UI. And at the time, it was really difficult to get it started unless you wanted to do virtual env in Python, on Windows. And I'm like, well, I'm sorry, I'm a Linux guy. I also don't want to run using different type of services. I don't want to run as root. So I built a solution which is called Comfy UI NVIDIA Docker, and all it does is that it's designed for NVIDIA GPU. So if you have an AMD hardware, I'm sorry, I can't help you. I built it specifically for PyTorch and CUDA. What it does is that it makes it possible for you to run as a Comfy user. Why is that important? Simply because inside container, outside container privileges matter. So if you mount a folder as yourself within the container, you're able to write to that folder. Why? Models are huge. We're talking gigabytes, and every week you're going to update a model. So I have about 4 terabytes of models on my home infra, and I need more storage. So if somebody has a spare NVMe's, I'm here, right? But yeah, so that's the idea. You need to be able to support that. You want also to be able to integrate user scripts. And the reason I say that is that for one example in particular, we're going to use a few different type of optimizations that are not built into Comfy UI, and you need to basically build from source. I have that enabled in my system. I also have something which is called the run dir and the base dir. The run dir is where I'm going to put the VM, and the base dir is where you're going to put your model. Big advantage is that if you want to do a clean install, you can still keep your models and wipe your VM. So it makes it possible for you to change version very easily. And I also have control for the security levels. So before I show the first demo, which hopefully we'll do live, I just want to give you a few analogies about stable diffusion, because you're going to see those things on every of those workflows I'm going to be showing. The model is basically what's going to be generating the image. If you think that's basically the painter, right? The clip is what I was saying earlier. That's what's going to transform the text into concept classes for the model. So that's the translator. We have the LoRA. A LoRA is a low-ranked adaptation, and I'm going to be showing you specifically a LoRA in a minute. And it's basically what makes it possible for you to add different style or different characters inside an image. And the way you train them is that you give it a specific name that is not present in the model, or replace a class in the model in order to show the result. So when you think about it, it's like do it in the style of Van Gogh, right? That you could do that with a LoRA. The sampler is just what refines the random noise, the noise, which is random, making it less and less random until you get an image. So that's the painting model. And the latent is the source image. So it's very useful when you do image to image, because you can use a previous image to transform it to become another image. Okay? So if you start text to image, you start with a blank latent. But if you do image to image, you have a source image. And that's what the latent makes possible. The VAE is basically just what converts from the representation into the latent space into pixels. So, you know, what the model understands, what we can see. All right, so in order to run the container, like I said, you need Docker. You need Docker Compose in that particular example. We're going to use Tailscale. If you're not familiar with Tailscale, it's a wonderful tool that makes it possible for you to interconnect any node you have on a private VPN overlay network. So all your nodes talk to one another wherever you are without having to expose a port. For people that do security, great tool. NVIDIA, obviously. So I made it possible to run most of the workflows here with 24 gig of VRAM, 3090, 4090, 5090. 16 gig of VRAM you would be able to do with an FP8. So if you change the quantization of the model to make it fit into less VRAM. But I'm not going to do that here because I have a big GPU. I'm going to use it. And finally, you need something that supports Comfy UI. So I built a container. I'm going to use my own container, right? All right. So when you deploy it, here is a Docker Compose. It's going to be available inside the GitHub. But basically, all I want to show you is that you have control over the UID, the GID, the base directory, and the security level for Comfy UI. You also have Tailscale network that's going to deploy everything so that I don't have to expose a port. You'll notice in the Comfy UI container, I don't have any port exposed. That's what we want. All right, so I'm going to skip that, and I'm going to try to go to a workflow. This is Comfy UI running, okay? It's running on a 100 IP, so that's an unroutable IP. That's over my Tailscale connection. So that's why I said, as long as I have internet, I can do live demo. You're going to see the different components I talked about. You have the clip, you have the model, you have the latent image size, you have the noise, and you have the seed for the noise. If you use the same seed, you're going to get the same result, as long as you have the same text as the input, right? And you have the sampler, and here is what we're going to be doing. We're going to do a giraffe. Why not start with a giraffe, right? I told you I'm going to do a giraffe. So here is a giraffe on roller skate, and we have a speech bubble that says Open Infra 2025. So I'm going to click Run. It's going to be super quick because, as you can see, I've already generated it right before. But here is a giraffe with roller skate with a speech bubble Open Infra 2025. That's about 10 seconds of generation on the H100. So I'm going to go back to my presentation. Now, I talked to you earlier about LoRAs. LoRAs are basically techniques that makes it possible for you to train, to extend a model with new concepts. A LoRA is a low-rank adaptation, and I'm going to be showing you a TOC-man. So what is a TOC-man? A TOC is a token, which is, you know, when you do LLM, you've heard about tokenization. It's a name that does not exist or is often used into the source model. So I trained that one on a 4090 because I did that last year. For people that are curious, my blog post on the subject, jkr.1, geekier1, that's my nick. I own the domain, so if you're curious, I wrote a blog post last year on how to train your own LoRA on image of yourself, which is exactly what we're going to be doing. So, what to know? You need 25 images of yourself with different, 20 to 25 images of yourself with different angle, different lighting condition, remove your glasses, put a hat on, things like that. The idea is that the AI, when it works, is here to train on what is common in all the picture. So if you always wear glasses, if you always are in front of the same background, it becomes part of the model, and then you're always going to have that result. So the more diversity you have, the better the chance that the AI is going to be able to generate something useful to you. Hardware, a 4090. Remember I said you need 24 gig of VRAM to run that? And it takes about 2.5 hours on a 4090 to train. So, and that's just for one LoRA, okay? Now, the LoRA, which for a model that takes 24 gig, is now 200 meg. 200 meg is not much. I mean, you know, if somebody told me that I would fit in 200 meg, I would have been like, yeah, I feel like I'm a little bulkier, but you know. So here is what training a LoRA looks like. Here is every 200 steps, up to 4,000 steps. And you can see that it's getting better and better at doing images of me. So that, by the way, if you're curious, that a professional photograph of a TOC-man, you know, black and white. Okay, so I still don't understand why a professional photograph has me wear a cap, but you know, we'll figure that one out later together. All right, with that said, what we're gonna do next is actually use that model that we trained. So I'm gonna check if I can do the live demo, which basically means loading the workflow, that one, and clicking run. So what we're doing is we're doing a professional black and white upper body shot of a TOC-man wearing a dress shirt. The word Open Infra 2025 are floating colorful with light, creating a beautiful contrast. So, don't fail me now. The GPU is waiting for something, I don't know what. There we go. So you can see the GPU is starting to be used, and once it gets started, it goes super fast. There we go. And so if anybody asks me for a professional shot, I don't have to do anything anymore. I can just AI generate myself. I think that's a pretty good result. Here's another example using the exact same technique. So the model is already loaded in memory, so all we have to do is the sampler. There we go. And this one is also Open Infra, but me wearing a suit in black and white, right? Keep those in mind because we're gonna have that conversation for the next step. So let's go to the next example. All right, let's talk about, everybody has tried to do an anime version of yourself using ChatGPT or virtual launcher. Well, the good news is you don't have to use that. You can do it at all on your own GPU if you use models that are designed to do that. Flux Context is one such model. There are multiple of them available. That one is actually downloadable and you can run it on your own hardware. So the way it works is that you're going to provide an image, you're going to provide instruction, and you're going to wait for the model to basically do the conversion for you. So you can do it. You can do edits. So you can change, for example, the clothes. You can change the style. You just have to tell it what you expect it to do, right? And it is able to keep consistency of content that's already in there. If you remember what I said earlier, we have a latent space, and so basically it's doing what is called an image-to-image transformation. So it's using an already existing image to make transformation on the image. So the workflow is also available. So I'm going to be running that one, and I'm going to find that one. I'm going to find the first one. So the first one is another large workflow, right? And we're going to give it as the input the last image we use. So that one in color. I'm sorry, it's really hard to stop. So we're going to use that one, and what we're going to have it do is that we're going to have it, from the provided reference image, create a unified cohesive image so that the photograph is now in color, and remove the text. Okay? The rest is just additional information to make sure that we have consistency in the result. So it's going to take a few seconds for it to load the model. There we go. It loaded the image in memory. It's loading the model inside the VRAM. Okay, this takes a few seconds. Come on. There we go. Now we're moving to the sampler. You can see the sampler is moving back forward. And network, don't fail me now. There we go. And here is the same image that you just saw in color without the text. All right, so that's a cool example, but I'll be honest, you have to pay me to wear a suit. You know, that's very honest. I don't wear suits, so let's just get rid of the suit. You know, I'm a geek. So what I do is I wear geek clothes. So we're going to take that image. Oh, it's not taking the wrong image. I'll have to change that. Yep. And obviously that's it. So we're going to change the input image to be that one. Alright, so that's 32. I'm going to take 33. No, it would be 34. Right. There we go. So we're going to start with the color image, right? The one not in black and white. And without the logo. Wait, I said 34. 34. 34. Live demos, I tell you. All right. So we're gonna wait. It should be fairly fast because everything is in memory. And here we go. That's more me, right? That's gonna be me in front of the server rack wearing a hoodie. All right. That said, we are at the Open Infra Summit. So let's just make that slightly different. We're gonna make sure I load the right image, by the way, this time. Yep, it's not the right thing. So 36. There we go. We're gonna take that one as an input, and I need the Open Infra logo. And with that, we're gonna basically use two images this time, and we're gonna basically add the logo to the source image. Also, you know, it's warm enough, I can wear a shirt. So let's go with that. There you go. That's me wearing a shirt with the same background, but I actually added the Open Infra logo to that image. All right, final thing is, you know, earlier I said we were gonna, everybody wants to get their anime version of themselves, so let's get my anime version. All I have to do is to load the right image, refresh, 37. And you can see it's basically using the last generated image, right? The prompt this time is basically just to say stylize as an anime character. You'll notice that I have, you might not see it, but I have fixed the seed because I know exactly what result I'm gonna get. If I was to do a random seed, the result might be weird like the previous one. So, there you go. That's me and an anime character. I always like that one. Okay.
And because I logged the seed, I can show you what I was expecting to receive, right? So the good news is I got the same thing. With that said, there is one more thing I want to show you, and I can just have time. It's when to animate. And I might have to, if it takes too long, I might have to run through the video. So you might have seen influencers basically show themselves as different characters on social media recently. Well, good news is you can do it at all. That's actually what when-to-animate is. It's a workflow that makes it possible for you to basically take yourself, do a video of yourself doing something, upload that video to the process, and then tell it to basically do a pre-process to generate the result. So I'm gonna go quickly because I don't know how long it's gonna take to generate, but the idea is that in that workflow, we're gonna load what's called a pre-processing pipeline. And that pre-processing pipeline is gonna take that video, it's gonna extract my face. It's also gonna do what is called pose estimation. So it's going to it's going to do wireframe of my hands, for example, like that, in order to use as a source for the generation of the result. And then it's going to create a mask. We're going to give it what we want to be replaced with, in that case, my anime version. And we're going to be basically generating a new video that matches the source video to generate the output. So with that said, try to do it live. That's the only one I'm not sure if it's going to work live. Right. So everything is loaded. Okay. So you can see I recorded a video. And okay. Okay. So right now it's working on extracting my face. Okay. And you can see the wireframe, which is basically the movement of my hand, and that is what it's going to be working with as a mask. So that's where it's going to be replacing the image. You have my anime version, and I expect it's going to be running for a minute. So I don't even see it running. Is it already done? Okay. Well, it appears it's done. So here's basically the result, which is thank you for coming. Have a great day. You'll notice that in the image, I also told it, since we're stable diffusion, I make my hands out of the sideboard. But you can see that's basically 5 seconds. It takes a minute on the H100 to generate. Let's see. Oh yeah, that's just a picture. So thank you. Obviously, AI generated me. That was one of the first one I did a year ago. It's, like I said, if somebody needs me for a presentation, I can send AI me now. It's a lot easier. And if you are curious and you want to play at home, I am serious. That's the GitHub that has been made public like 20 minutes ago. For you to actually do all those workflows at home. It explains how to do the Docker Compose, how to set it up, and have some fun. So I think I have like 2 minutes for questions. But if you want to talk to me, I'm around. I'm going to be at 4. I'm going to be at the open source pavilion. Now that I've done, I can do all the demos. If people are curious, I can do more demos. We can make more giraffes. People like giraffes. And things like that. So let me know.
Well, I guess the people on the feed are not going to like me. Well, let me know if you have questions.